In the next few videos, we'll take a look at some other important networking protocols that you may come across as a system administrator. The first one we'll review is the Simple Network Management Protocol, or SNMP. It was first developed in 1988 as a way for system administrators to query information from a variety of devices on a network and possibly even update that information as needed. Remember that in 1988, this was well before the development of the web browsers we know today, so it wasn't as simple as using the web-based configuration interface present on most routers today. However, while most systems today support SNMP, it is primarily used for remote monitoring of network equipment and not as much for configuration as it was originally intended. Over the years, there have been many different versions of SNMP developed. Each one includes a few different features. The first version, SNMP V1, is very basic. While it works well for some things, it only includes a plain text community string for authentication, resulting in minimal security. SNMP V2 is a significant revision to SNMP V1 and includes a much more robust security model. However, many users found that new security model to be overly complex, and a second version called SNMP V2C for Community was developed without the new security model. Finally, SNMP V3 was developed to include much better security, authentication, and a more user-friendly design. It's the only currently accepted standard, though many devices still use the older versions as well. In SNMP, the data is presented in the form of variables. The variables themselves have a very hierarchical structure so that similar types of data are grouped together. However, the variables themselves can be difficult to read directly since each level of the hierarchy is denoted by a number instead of a name. To help make the variables more readable, SNMP includes a Management Information Base, or MIB, to define what each variable means. Each individual device can define its own MIB, though there are some standards available for common types of data. You can find a couple of those standards linked below this video. The SNMP protocol itself lists many different types of protocol data units, or PDUs, as part of the standard. For example, the GetRequest PDU is used to query a particular variable on a device, and the response PDU would be sent back from that device. You'll be able to see several of these PDUs a bit later in this video when we use Wireshark to capture some SNMP packets. As mentioned earlier, one feature of SNMP is the use of a community string for authentication. In SNMP version 1, the community string was a simple text identifier that you can provide along with your request. The server then determines if that community string has access to the variable it requested, and if so, it will return the appropriate response. However, since community strings are sent as plain text, anyone who is able to intercept a packet could find the community string, so it really wasn't very secure. In later versions of SNMP, additional security features were added to resolve this issue. In this video, we'll see an example of using SNMP version 3 with proper security and encryption. Now that you know a bit about SNMP, let's see a quick example of how it works. Once again, I've configured an Ubuntu VM as directed in Lab 3 to act as an SNMP server, and I've also configured a second Ubuntu VM to act as an SNMP manager or client. First, on my server, I'm going to start Wireshark so we can capture these packets. Notice that I'm capturing packets on the Ethernet adapter since I'll be accessing it from another system. I'll also add a filter for SNMP to make sure we only see the SNMP server packets. Next, on the client system, we can query the data available using SNMP with a couple of different commands. First, I'm going to use the simple SNMP get command to query a single variable. I've already configured the system to use a set of authentication credentials stored in a configuration file, which you can do as part of the Lab 3 assignment. In this case, I'll query the system's uptime. In the response, we can clearly see the system's uptime. Now, if we switch back to Wireshark, we should see that it captured some SNMP packets. If we were using SNMP version 1, these would be in plain text and we could read the information here very clearly. However, since we're now using SNMP version 3, it is encrypted. To see all of the available SNMP variables on our system, we can use the following command, SNMP walk, followed by the IP address of the server. This command will result in thousands of lines of output, giving all of the variables available on the system. Looking at Wireshark, we can also see that there are lots and lots of SNMP packets being transmitted. In fact, each one of those data items requires a single packet to be transmitted. Since it's very difficult to find exactly what we're looking for using the SNMP walk command, we can combine it using grep. For example, to see all of the variables related to TCP, I would do something like this. SNMP walk, pipe to grep, followed by TCP-MIB. If we know the set of variables we'd like to query in advance, we can also include them as part of the SNMP walk command so that it doesn't have to request all of them. For example, I can do SNMP walk followed by the IP address and then TCP-MIB:TCP. Either way, we should see the variables related to TCP. In the lab assignment, you'll need to query some information about a different set of variables, so you may have to do some digging in the documentation on your own to find the right ones. That's a quick overview of how to use SNMP to query information about your system across the network. If you have any questions or trouble getting it configured on your system, use the course discussion forums on Canvas to ask us a question anytime.